Hello students, welcome to Vista's Learning. This is Shruti, your chemistry tutor. We are in Vista's Learning where you get a quality education for all as we work for right to quality education for all. Students, we are in 11th standard chemistry and we'll check out with the chapter. What is the chapter we are into? It is hydrogen, which is the chapter. It is hydrogen, chapter number 9. And this is the lecture 2. We have already started with our lecture 1 where we have studied about the basic introduction about hydrogen, preparation of hydrogen. In preparation, we have commercial preparation as well as laboratory preparation. Already we have studied. If you missed that video, get back into our web application www.v-learning.in and you'll get the other videos if you have missed any of them. And in this, we'll study about hydrogen. We know hydrogen has been used in many things and not only in industrial uses but also it is used as a fuel and for synthesis of many things. We'll just check it out now. The chemical properties of hydrogen, right? What we are checking with, we are learning about the chemical properties of hydrogen. What are the chemical properties, students? Chemical properties means how the hydrogen will be reacting with other elements. What are the elements we know? We know elements are categorized into metals and non-metals mainly, right? We also have metalloids. So, how does this hydrogen reacts with metal as well as non-metal? That gives you the chemical properties of hydrogen. The first thing, if you see reaction with halogen. Halogen is a metal or a non-metal? It is a non-metal, 17 group element, right? So halogens, how does the hydrogen react with halogen? So hydrogen reacts with halogen to give hydrogen halide. In general, halogen will be represented with the X. That means X can be fluorine, chlorine, bromine, iodine. Okay? So we'll just check with the example, hydrogen reacting with the halogen, where you should know that halogen is also a diatomic molecule, hydrogen is also a diatomic molecule. They both react to give two molecules of hydrogen halide. We have hydrogen with one electron in the outermost orbit. Likewise, if you see chlorine, bromine, iodine or fluorine, the halogens will have 7 electrons in the outermost shell. 2, 4, 6 and 1. 7. Okay. So what happens? This requires one more electron to attain the stability, whereas the hydrogen also requires, if I take this as a chlorine, hydrogen also requires one electron to attain stability. So what do? They combine together, they share the electrons and become a molecule. So one atom of hydrogen reacts with one atom of chlorine to give one atom of hydrochloric acid. Got this? So here we can take in place of X fluorine, chlorine, bromine and iodine. So reaction with halogens. Hydrogen reacts with halogens to get hydrogen halide. You can call this as, if I take fluorine, hydrogen fluoride, hydrogen chloride, hydrogen bromide, hydrogen iodide. Okay. Whereas hydrogen chloride, we also call it as hydrochloric acid. Next one. Fluorine occurs in dark, whereas iodine requires a catalyst. So here we know that down the group where fluorine, chlorine, bromine and iodine is present, down the group reactivity decreases. That means fluorine is most reactive element among halogens, whereas iodine is least reactive element. So what happens here is that the fluorine can react in dark with the hydrogen. If I take a dark bottle or in a dark room, if the reaction is taking place, the fluorine can react in the dark place with hydrogen, whereas iodine requires some more catalyst. It requires some other chemical to enhance the reaction. Got it? So that means that fluorine is more reactive, iodine is least reactive with hydrogen. Next, reaction with dioxygen. As I said, we are seeing the chemical properties. Chemical properties means reaction with hydrogen, reaction of hydrogen with metals and non-metals. So we are discussing about the most reactive non-metals. So most reactive non-metal is halogen. After halogen we have dioxygen. Dioxygen is nothing but oxygen molecule. Why we call it as dioxygen? Because oxygen is also a diatomic molecule, hence we call it as dioxygen. Hydrogen reacts with oxygen? Yes, obviously yes. What is the product we get? We get water, which is very useful for all living organisms. So we get water when hydrogen reacts with oxygen. It is highly exothermic reaction, very high, huge amount of energy is being evolved. You can see hydrogen molecule reacts with oxygen molecule to give 2 molecules of water. When we take 2 molecules of hydrogen, 1 molecule of oxygen, it is 2:1 in ratio, where we get minus 285.9 kilojoules per mole. You know that the students, the enthalpy, if it is negative, the enthalpy is negative, that means it has been evolved, the energy is been given out. So such a high amount of energy is been released when hydrogen is combined with oxygen. That means it is a very high stable molecule and it gives you the exothermic reaction because energy is been evolved. Got it? Next one, reaction with dinitrogen. When you see with the periodic table, we have halogen 17 group, oxygen 16 group, and the 15 group we have nitrogen. So what happens when hydrogen reacts with nitrogen? With nitrogen, it forms ammonia. We know that it forms ammonia. What is ammonia? NH3 is called as ammonia. So this ammonia is not directly formed. It requires the catalyst called iron, whereas it takes place at a higher temperature, 273 Kelvin, and at a higher pressure, 200 atmospheric pressure. So hydrogen reacts with nitrogen to give ammonia. You can see here 2 nitrogen atoms, that is nitrogen molecule, reacts with 3 hydrogen molecules to give 2 ammonia, NH3. So each nitrogen will have 3 hydrogen atoms with it, where it gets NH3. Got it? Yes. Next, reaction with metals. Now we studied about non-metals, hydrogen reacting with non-metals. We'll check how does hydrogen react with metals. We have already studied about the comparison between hydrogen with alkali metals as well as hydrogen with halogens. Now we'll check how does it react with metals. So at a higher temperature, it combines with metal to get hydrides. It combines with metals to get hydrides. We call it as metallic hydride. So we know that 1 electron is there in the hydrogen, where it requires 1 more electron, and here when it has been reacting with metals can easily donate electrons. Hence hydrogen can get 1 electron easily and it becomes H-. That means hydride. Okay, when it is been reacting with non-metals, it can become H plus the proton, whereas when it is been reacting with metals, it gain electron since it is more electronegative than metals, and it becomes hydrides. So we call the compound which is formed is as hydrides. So if you see hydrogen, M is metal. So hydrogen reacting with metal, we get MH, that is metallic hydride. Here metal is being taken as alkali metal. If I take an example, hydrogen reacting with lithium. Lithium is alkali metal? Yes. So what is the reaction I get? Lithium have one electron in the outermost shell. It donates one electron, and hence I get LiH, lithium hydride. It is not balanced. To balance, I'll add 2 here such that the hydrogen is balanced. Here lithium is not balanced. I add 2 on the reactant side. So now it is being balanced. Hence we get the general formula H2 2M, which gives you 2MH, where M is alkali metal. You can also take in presence of M sodium Na, which gives you sodium hydride. Likewise, potassium, rubidium, cesium, francium, any of the examples we can take. Next, reaction with metal ions and metal oxides. So we know the ions are being formed by removal of electron from the metal. Hence we get the metal ions and metal oxides. When metals are reacted with oxygen, we get metal oxides. How does this hydrogen react with these ions and metal oxides? So if you see, hydrogen reacts with palladium plus 2, where it gives you palladium plus 2H plus. That means it requires 2 electrons. Hydrogen donates its electron and become proton. As it has only 1 electron, if I have any of the, for example, PD2 plus, if I have, this electron will be donated to PD, and 1 more hydrogen, I'll take 2 hydrogen atoms. So 2 electrons can be given to palladium. So it becomes PD, right? PD2 plus becomes PD, where H becomes H plus. So how many atoms will be present in one molecule? 2. So we get 2H plus. Got it? Hence we have the 2 protons released when hydrogen is being reacted with palladium 2 plus to give palladium and hydrogen. The general equation for metal oxides and hydrogen. When hydrogen reacts with metallic oxide, we get water plus that metal. We can see the example here. Copper oxide, when it is been reacting with hydrogen, we get copper which is been removed with the water molecule. Getting that? Likewise, lead oxide, when lead oxide is being reacted with hydrogen gas, you can see all these oxides are in solid form, hydrogen is in gaseous form. When hydrogen hits the solid, what happens? It reacts with hydrogen to give water, whereas the element or the metal is been removed out. Likewise, iron oxide, when reacted with hydrogen, we get water molecule with iron. So we can say when hydrogen is reacted with metallic oxide, we get metal plus water molecule. Next we are going ahead with, we finished with elements, metals and non-metals. Now we are studying with the organic compounds, reaction of hydrogen with organic compounds. So what happens with what do you mean by organic compounds first of all? So organic compounds are the compounds which are derived from plants or animal products, where it contains carbon and its compounds, right? So here when we take the vegetable oils, vegetables are derived from plants and they will be containing carbon compounds. So hydrogenation of these vegetable oils in presence of nickel as a catalyst gives you edible fats. That reaction will be given by reaction with organic compounds with hydrogen. So we can say the utility of hydrogenation can be done for converting vegetable oils into edible oils. Next, hydroformylation of olefins yields aldehydes which further undergo reduction to give alcohols. That means from olefins we can get aldehydes and alcohols by hydrogenation. We can also say hydroformylation. H2 is a hydrogen. When it reacts with carbon monoxide and olefins, we get the aldehydes. Hydrogen, when it is reacting with aldehyde, in fact, we get alcohols. Got this? Understood? Here, double bond gives you alkene, whereas the CHO informs you it is aldehyde. OH gives you alcohol. So you can take this R as extended form of carbon. Okay students, because these olefins or oils are a larger units. They are the polymers. So you can take R as a branch of carbon and you will get a branch of carbon which is added here, where you can just have the reaction with these things where CH double bond CH2 convert, this part will be converted as CH2 CHO, where that CHO will be converted back as CH2OH. From olefins to aldehyde, from aldehyde to alcohol. What they are doing? They are just adding water, hydrogen molecules to the given aldehydes. Hence we get the reaction as such. How do you get this? C double bond H you will be having. On addition of hydrogen here, the CH2. On addition of hydrogen, what happens? The hydrogen will go here. So one more hydrogen will be added here. We get one C as it is, this one, and this C. Here one H, here OH, here H, and here H. So from this to this, how many hydrogen is been added? 2 hydrogen is been added. So the hydrogenation can be used for conversion of aldehyde to alcohol. Hope you are understanding this. Good. So here we have the hydrogen, where and all you are utilizing it. So you can see hydrogen has been converted as ammonia and it is been used as a fertilizer, because we know nitrogen is very much important for the leguminous plants or the plants which are having proteins, which give or which produces proteins like groundnut and peas and all requires nitrogen because they are good or rich in protein. How do the protein is being produced? They are the compounds of nitrogen. If you don't have or if you lack the nitrogen, protein cannot be easily formed from the plants. So we require nitrogen. We add the nitrogen to the plants such that it will give the fertilization for that. Or else we also convert this ammonia into urea and then we use it as a fertilizer. And this hydrogen can also be used as a fuel. When we pass the electricity to the electricity through the water, the split water molecule will split into hydrogen and oxygen, where that hydrogen we are utilizing as the fuel. You can see it can be used for the fuel, and also it is a combustible where it gives you very least or it gives no pollutants. You can use that as a fuel for running the vehicles too. Hope you are understanding this. We'll get into with the uses of this dihydrogen. It is used in synthesis of ammonia, which is used in the manufacture of nitric acid as well as nitrogenous fertilizers. Hydrogenation of polyunsaturated vegetable oils like soybean and coconut seeds, etc. That means the hydrogenation of unsaturated one. Unsaturated means it contains double bond and triple bond. To saturate them, we are using this hydrogen. Which are the oils we are using? We can give the example of coconut seed oil, whereas we can also use a soybean oil. In manufacture of bulk organic chemicals, particularly what is this? Methanol. Methanol is very much important, students, for the industries. For preparation of methanol, we require this hydrogen. We can see carbon monoxide is reacted with hydrogen to get methanol. So here we cobalt acts as a catalyst. Catalyst, you know, right? It will not take part in the chemical reaction, but it enhances the rate of the reaction. And hydrogen is also used in the manufacture of metal hydrates. We know chemical properties, what and all we have learnt. What are the chemical properties of hydrogen? When it is been reacted with metals, we get metallic hydrides. When it is been reacted with non-metals, we get ammonia, right? So that uses, we are just using as a uses of hydrogen. So in preparation of hydrogen chloride, this also we studied. So what and all the chemical properties are there? They are also the uses of hydrogen. It has been used to reduce heavy metallic oxides into metals in metallurgy. As we saw, copper oxide is been reduced to copper, iron oxide is been reduced to iron. To eradicate the metals from the ores in metallurgy, we are using this hydrogen to reduce the metal oxides to metals. Next one is that atomic hydrogen and oxyhydrogen is used for cutting and welding purposes. You can see the person who is welding will be having that sharp fire, right? That gives this hydrogen and oxyhydrogen will give you a higher temperature around 4000 Kelvin for preparing or welding purposes. So that high temperature can be easily used by hydrogen. It is also used as a fuel for rocket in space research. It is used as a fuel cells for generating electrical energy. We know that. It doesn't produce any pollution, as I said, and release great energy per unit mass of fuel in comparison to gasoline and other fuels. So in comparison with other fuels, this hydrogen have least pollutants. We can also say it doesn't produce any pollutants. So that is very much eco-friendly. So by this, we end with the session, students. In the next class, we'll know much more about this hydrogen and water molecule, structure of water molecule, structure of ice and structure of water. What is the difference? And in detail, we'll study about hard and soft water. So hope you understood this. If you have any of the doubts, we are here to guide you, help you in your studies. You're always welcome, students. Thanks for watching.